Okay students, let us start today's topic, that is application of derivative, and we'll be covering three particular subtopics of AOD. So today class we'll be covering tangents and normal, rate measure, errors and approximation, and from this is where the main this is the main topic of differential calculus, and this is the chunk of it which has been asked in the examination. So in the tangents and normal we are going to do slope and their equation. Both the equations are the questions come on two categories, that is slope and the equation for both normal and tangents. Then we'll have angle between the curves, and then the length of tangent, normal, subtangent and subnormal. So this is another category which is being covered in tangents and normal topic. Then we'll do the some questions on rate measure. It's again a very basic chapter, but somehow very important as per se your entrance engineering examinations. Similarly, we'll do basic things on entrance errors and approximation. So everything is very important as per se your both board levels as well as the entrance examinations. So keep focused, study the lecture very thoroughly. Okay, so let's start with tangents and normal first of all. So let us first of all understand the basics of tangents and normal. So there are two categories of questions which are being asked. So if I have to write, so there are two categories, right? So and both the categories are very easy to solve. So either they will ask you slope related problems, right? Slope related problems. Either the slope is related to the tangent or it is related to the normal, or they will ask you equation related problems, right? Equation of tangent or equation of normal related problems. So these are the two things that are being asked in this particular concept, right? Apart from the angle between the curves and the length of tangent and subtangent, which we'll do a bit later. So what is meant by here? So let's go into a bit briefing of what do you mean by slope and all this. So we did dy by dx, right? So what do you mean by dy by dx? Dy by dx is nothing but slope of a tangent at a point, right? The value of dy by dx is nothing but slope of tangent. Why? Because we did this in differentiation, that dy by dx can be written as delta y by delta x as delta x approaches 0. So that means you are trying to measure change in y with respect to change in x. Don't worry, we'll do this definition also in rate measure, right? So if you see this becomes y2 minus delta y is y2 minus y1, and this becomes x2 minus x1, which is nothing but definition of a slope. This is how you calculate slope, right? So dy by dx is nothing but dy by dx, if we talk about, is slope at a point, slope of tangent at a point, right? So this means when you know the derivative, you know the slope of tangent at a point. Okay, so anybody who asks you find the slope of tangent, then that means you, let's say this p point is x1 and y1, and this c curve, this here c curve is y is equal to fx, for example, right? So if you want the slope at p point, so mp, right, this means the slope of the tangent at p point, it will be nothing but f dash x1, that is derivative of the function at x1, or you can write this also as dy by dx at x1 y1, in whichever way you want to write. So this gives you the slope component, right? And if you want to write the equation of the tangent, so what you will say about the equation of tangent then? Yes, we know this is simple, very simple. Why? Because we know a point and the slope. So the equation of tangent will be nothing given as y minus y1 is equal to mp x minus x1. So this is the equation of tangent over here. So if this is the slope of the tangent, then how you can find the slope of normal? So slope of normal at p would be what? Yes, reciprocal of this and minus sign. So slope of normal at p would be nothing but minus 1 by mp. We have already done this, right? Remember? So an equation of normal then can be written as, very easily it could be written as y minus y1 is equal to minus 1 by mp x minus x1. So this is the basic concept which is being used in this entire chapter, that either you will be asked the slope or based questions, or you will be asked equation based questions, and this is what you people have to remember. Okay, now let's directly apply this concept that we have learned into the questions. So let us apply straight away the concepts in the basic questions. You need to find the points on this particular curve where the tangents are vertical. Okay, so where the tangent is vertical, so what do you mean by tangent is vertical? So that means it is parallel to y-axis, right? So any line which is parallel to y-axis is of the form x is equal to constant, right? This is what we know. And what is the slope of such lines? So lines which are parallel to y-axis have slope as infinity, remember, because you will get something of tan 90 degree, so their slope should be infinite, right? So this is the concept that you people will have to use for vertical line, that m of this should come out to be infinity. So our target is to say that dy by dx of this particular question should come out to be infinity. So how do we solve this? So remember that this may be a implicit function or a explicit function, it doesn't matter. You just have to differentiate, because we want to find target. Let's say if I start writing what is the target, so target is again to find dy by dx and equate it to be infinity. So let's start, just differentiate this. So what you people will get is 3y square dy by dx, right? 3y square dy by dx plus 6x is equal to 12 dy by dx. This is what you will get, right? And if we club everything, what you will get, y square minus 4 dy by dx, right, is equal to minus 2x, and dy by dx will be nothing but equal to minus 2x divided by y square minus 4. This is what you will get. You want that this should be equal to infinity, right? So if we take this to be equal to infinity, we want this value to come out to be equal to infinity. So what we can say about infinity, infinity or 1 by 0 is one and the same thing, because tan 90 is 1 by 0, and that is why we say it is infinity. Please do not get into the depth of this, sir, that we cannot say 1 by 0 as infinity, this is undefined. This just, you remember it like this. Don't waste your time over this particular concept over here. So the slope can be infinity when the denominator is 0. So this particular quantity has to be 0. So this implies y square minus 4 should be equal to 0. This happens at two values of y, that is plus minus 2. So you have actually 2 points which should satisfy this particular criteria, because y is plus minus 2. So calculate x in terms of this. So 3x square is equal to 12y minus y cube. Can we say this? Right? So if you put the values, what you will get, 3x square is equal to, so these two values you will get, that 3x square is equal to 16 for y equal to 2, and 3x square is equal to minus 16 for y equal to minus 2. And obviously we can say that this is not the answer. Why? Because 3x square cannot be a negative quantity. So the only answer that we should obtain is this particular step. So x square comes out to be that 16 by 3. So this implies that x is equal to plus minus 4 by root 3. This is the 2 points. So the 2 points that we are getting is plus minus 4 by root 3 comma 2. So these are the 2 points where the tangent would be vertical, that is parallel to y-axis, and this is our particular answer. This is how you solve this. Got it? Now let's take the other problem. It says find the slope of the tangent at 2, 1 to the curve, something like this. So first of all, here the curve is given to be in the parametric form, right? So this is another category of question that is generally being asked, that the curve is given in the parametric form. So how do we solve parametric form? We know that, so we don't have to worry too much about this. So x is given to be as t square plus 3t minus 8, y is given to be 2t square minus 2t minus 5, right? So these things are given in terms of, so let's say this is ft, which is given to you, and this is gt. Now our target is to find the slope of tangent at 2, minus 1. So for slope, what you want? You want dy by dx, but since it is a parametric form, so what we can say, dy by dt divided by dx by dt. Can we do this? Yes, absolutely. This is completely valid. So you just do what? First of all, calculate dy by dt. So what is the value at dy by dt? We know that if you do that, this will be 4t minus 2, and if you solve dx by dt, what you will get at dx by dt? So dx by dt will be 2t plus 3. Okay, but the problem is that you wanted to find this at the point 2, 1. So when I say 2, minus 1, so what are these values? So this implies that x is equal to 2 and y is equal to minus 1, whereas what you have got, dy by dx will be this divided by this, that is 4t minus 2 by 2t plus 3. So for calculating this, you need value of t, whereas you are given the values of x and y. So this is something very easy now. So what you can do, just substitute the value of x here. So you need that value of t for which x comes out to be t and for which y will become, yes, -1. So you need that value of t which will satisfy both these conditions. Okay, and simply if we just solve very quickly, you can see that this is a very plain equation. This comes out to be t plus 5 into t minus 2. So here two values that t is satisfying is 2 and -5. And similarly solve something over here. So it will give you what, 2t square minus 2t and minus 4 equal to 0. I can simplify it to write t square minus t minus 2 equal to 0, and this will again give me two solutions. What solutions can you tell me? Yes, it will give me t minus 2 into t plus 1 equal to 0. So here also you will get two values of t. Which is the common value of t which is satisfying both of them? Yes, that will be our answer, t equal to 2, t equal to 2. So that means our dy by dx at 2 comma minus 1 will be found nothing by replacing value of t in this particular component as yes. Okay, clear? So you just have to replace t equal to 2 here to get your answer. So if you just replace t equal to 2 here, what you will get? 8 minus 2, 6, right? So you should get something of, this will be 6, this will become, yes, 7. So 6 by 7 is your answer that we are looking for. I hope this question is now clear to you people. C is the answer. Okay, so the next problem says if the slope of this curve at point 1 comma 1 is 2, then you have to find values of a and b. So now this is the reverse method. In the earlier two questions, what we did, we found the equation of the line using the slope and whatever method was given to us. Here the slope of the curve is given. So here the curve is given to us that y is equal to fx is equal to ax upon b minus x. This is given to us. And also m at 1 comma 1 is given to be equal to 2, so this is also given, right? That means slope is given. So first target is to find dy by dx at 1 comma 1. So what will be the dy by dx? Okay, so for dy by dx we will have to use the quotient rule over here. What it will become, let's say we take a common outside, so this becomes b minus x, right, for the first derivative, minus, yes, what we will do then, minus plus x divided by b minus x whole square. Okay, and this will reduce to what? ab times b minus x whole square. So this is the value of dy by dx that we people will get very easily. Okay, now our target was to find dy by dx at what point? We wanted to find dy by dx at 1 comma 1. So that means we'll replace x by 1 over here. So this will become what? ab upon b minus 1 square. That is what we can say, and this is given to be actually equal to 2 to us. Okay, so the first equation that we obtained is ab is equal to 2 times b minus 1 whole square. Okay, so this is the first relation that we have got, but now we require another relation in terms of a and b because we have two variables, so we should get two equations. Yes, we have that in the equation. So people are thinking that where we will get it from. It is already there. It is said tangent at the point 1 comma 1. So when you say point 1 comma 1, so it must satisfy the curve. It should satisfy the equation of curve also, right? It should satisfy y equal to fx because the tangent is being drawn at this point, obviously. So this becomes y is equal to a upon b minus 1. I can say that b minus 1 is nothing but equal to a. So now you can simply solve this particular problem from here. Okay, so just replace the value of a in this particular equation. So what you will get here, by replacing, I can say b minus 1 into b is equal to 2 times b minus 1 square. So if you cancel b minus 1, so never cancel. In fact, what you should say, b minus 1 could also be 0, or b is equal to 2 times b minus 1. So one answer of the b that you people will get is b is equal to 1, or the other answer here would be b is equal to 2b minus 2, and you can say b is equal to nothing but 2. So we have two answers for b for this particular question. Okay, so for if b is equal to 1, then what will be the value of a that we will obtain? Just put b equal to 1 over here and you get a is equal to 0. And if b is equal to 2, we'll get a is equal to 1. So these are your two answers that we will obtain for this particular question. Got it? But if you answer me that these are the two answers, then yes, this is wrong. Now let us see about this particular pair that you are getting, that is a is equal to 0 and you are getting b equal to 1. If you put that in the y equal to fx component, can you see that your y will become equal to 0? Because it is ax upon b minus x, that is means it's a constant function, or we can say this is nothing but x-axis. So it cannot have a tangent at point 1 comma 1. That is the problem, because 1 comma 1 will no longer lie on this particular line. So that means this answer is not correct. Okay, now let me check for the other pair that you have, a is equal to 1 and b is equal to 2. So what your now the curve will become is, yes, your curve will become x upon what? Yes, 2 minus x. Now check whether 1 comma 1 satisfies this. Here 1 comma 1 satisfies, so I can say this is the correct answer of a and b. So what you should tell me as the answer is this value, not the other value, right? So there is only one answer, there are not two answers to this particular problem. So answer to this particular ordered pair is a is equal to 1 and b is equal to 2. This is the answer. Okay, now let's take the next problem. It says the curve y equal to, this is a cubic curve that is given to you, that is ax cube plus bx square plus cx plus 5. So there are three parameters as I can see, a, b and c. Touches the x-axis at p and cuts the y-axis at a point q where its gradient is 3. So now it's a bit tricky problem because it is asking you both the values of a, b and c. So let us just understand what is given to you in the question. So it is given that it is touching the x-axis at this and it cuts the y-axis at a point q where gradient. So what do you understand by gradient? I hope you understand what is meant by gradient. If not, then gradient means slope, right? The meaning of gradient is nothing but slope, right? So that means that slope of tangent, because the slope cannot be of a curve, right? Slope is always of a tangent. So slope of tangent at q is given to be equal to 3. This is what is given to you. And q point is where it cuts the y-axis. So at q, we also know that ordinate is 0, right? So the ordinate at q is equal to 0. This is what we know about this particular question as well. Okay. Now talking about the other things that are given to you in the question, it is giving touches the x-axis. So what do you understand by touches the x-axis? So touching is always means that it is a tangent, that means touching, right? So that means that x-axis becomes a tangent over here. So x-axis is a tangent, that means if x-axis is a tangent, that is m is equal to 0. At what point it is touching the x-axis? So slope at x equal to minus 2, I can say that slope is 0. So let's kickstart this question by this first property. It says dy by dx will become what? 3a x square plus 2bx plus c, right? It is given that the value of this at x equal to minus 2 should be what? 0. So the slope should be 0 at x equal to minus 2. So what it will become? 3a into 4, right, minus 2b into 2 plus c should be equal to 0. This is the first expression that I can say, right? So if you simplify this, what it will become? Yes, tell me. So this will be 12a minus 4b plus c equal to 0. So this, in fact, rather I should say this as the first one. Okay. What about the others? What can you tell about the others? Because since there are three parameters, so we require three different equations. Okay. Okay. Now we need to think of the other remaining properties. Slope of the tangent at q is given to be 3. Oh, sorry, this is a mistake. The at q abscissa would be 0. Some of you must be thinking that I have done the wrong. Yes, you are right. So this is that abscissa would be equal to 0. So can you tell me what will be the q point? Yes, the q point would be, just put abscissa, so that is x is equal to 0. Why? Because it is cutting the y-axis. At y-axis x is equal to 0, or you can say y-intercept. So y-intercept will be nothing but 5. So that means at 0, 5, I can say that m is equal to 3. This is also given to you people. So again apply the second condition here, that dy by dx at 0, 5 is nothing but 3. So if you do this step, that means at dy by dx at 0, 5. So what is your dy by dx? Sorry. So dy by dx is this particular expression. So dy by dx straight away will be c, right? And this is given to be 3. So we have now value of c straight away, that c is equal to 3. Now we need another equation to find a and b, right? I can now simplify this and write that this is plus 3 equal to 0. This I can say. I have still not used this particular condition over here. I have used that it has slope 0 at minus 2, but when I say it touches, now this is very important, it touches at P, so can you say that it passes through P also? Right, the curve passes through P, very very important. Okay, so minus 2 comma 0 will also satisfy the equation of the curve. Yes, it will satisfy. So if you just put this value over here, what you will get, let's see. So this is the expression that you will get after putting minus 2 comma 0 in this particular curve, right? So we can still simplify this. So this becomes what? Minus 8a plus 4b. We know that c is nothing but 3, so this will become minus 1. So what it will become? 8a minus 4b, right, plus 1 equal to 0. So can you see now that this is your, let's say, second equation, and this is your third equation, and if you just solve second and third, right, you will get your answer, because this is linear equation in two variable, both a and b are there, right? So I'm leaving that particular component for you people to solve this. All right, I hope the conceptually the question is very much clear. The answer that finally that you people should check and answer is that a will be minus 1 by 2 and b will be minus 3 by 4. But I suppose that the question is very much clear to you people now. Okay. Okay, now let's take this problem. It says find the area of the triangle formed by a tangent to this particular curve and the coordinate axis. So first of all, let us understand the problem. It says find the area formed by a tangent. So here is a challenge, because you always need the point where the tangent will be drawn. So it is not given to you. So for that example, I assume that point to be n, and I have taken its coordinate to be alpha comma beta. Right? I have drawn the tangent at m, whose coordinates are alpha comma beta, to this particular curve. So this is, let's say, the curve that we are talking about. You need to find the area of the triangle formed by the tangent and the coordinate axis. So this particular stuff is being asked of you. You are asked to find the area of this particular triangle. Get it? Okay, so how do we do that? Obviously, area of the triangle here. So the target is to find area of triangle, let's say OKT, in this particular diagram. Okay, so we need half OT into OK. This is our target. This is nothing but y-intercept of the line, and this is nothing but the x-intercept of the line. So you need to find x-intercept and y-intercept. For that you need equation of tangent, as simple as that. So the target is, the first target is in this question is to find the equation of tangent. So if we start with the tangent, you need to find tangent at alpha comma beta. The curve is 2xy is equal to a square, right? So you want to find dy by dx. Let's differentiate. So if we differentiate, what it will become? 2 can be taken on this side and then you can differentiate, right? So xy is equal to a square by 2. Why I have done that? Because this will completely be 0. So if you differentiate, this will become x dy by dx, right? Plus, if you differentiate, yeah, it's a very simple differentiation, equal to y. This implies dy by dx is nothing but minus y by x. So this is what you will obtain. Now you want the dy by dx to be at point m, and the coordinates of m we are taken as alpha and beta. So this will become minus beta by alpha, right? So what will be the equation of tangent? So equation of tangent at this point would be then y minus beta is equal to minus beta by alpha x minus alpha. This will be the equation. Okay, So how you want, in fact we should not need not resolve this because you want x-intercept and y-intercept out of this. So what will be the x-intercept? Can you tell me what will be the x-intercept? How do you find x-intercept? By putting y equal to 0. If you just put y equal to 0, can you see, just leave this component, minus b and minus b will get cancelled out. You will get something of the sort like this. So which will give you x is equal to 2 alpha. So that means this t point is nothing but 2 alpha comma 0. This we can easily see. Y-intercept, for y-intercept you will put x equal to 0. So if you put x equal to 0 here, what you will get? Your minus alpha, alpha and alpha will cancel out. This will be something like y minus beta is equal to beta, and for this you will get y is equal to 2 beta, right? And that means k point is nothing but 0 comma 2 beta. Now you need to find the area. I hope the question is now done and it is very much clear to you. So area of triangle OTK is nothing but half into 2 alpha into 2 beta. So the answer will come out to be 2 alpha beta. But this is not the answer. Why? If you say, sir, this is my answer, so then this is the wrong answer. Why? Because alpha beta were not given into the question. You have assumed alpha and beta, so you need to remove alpha beta from the answer, otherwise it will not match. But can you tell me that where does alpha beta lie? Alpha beta lies in the equation. It lies on the curve, so it will satisfy the equation of curve also, which is this one. So what it will become, if you satisfy this, becomes 2 alpha beta is equal to a square. So you have to tell me that answer is nothing but a square. If you notice, which is constant, it is independent of any variable, right? This is independent of any variable over here. Okay, so this is how this question has to be treated. It was asking you to find the area of a triangle. Irrespective of the point that you take, the area of this particular triangle between the coordinate x's will always be equal to a square, which is constant. Okay, so the next question is based on normal to the curve. So it says that the normal to the curve, this passes through a fixed point. You have to find that point. Okay, and the 4 options are given to you as well. So first of all, if you see that the equation of the curve that is given to you people is in the form of parametric form, right? So this is x is equal to 1 plus cos theta and y is given to be a sin theta, right? So for the equation of the normal, what we people will be asked to find? Yes, we will be asked to find dy by dx. So let's start with dy by dx again. So dy by dx of this particular equation would be what? Yes, you will have to apply parametric differentiation, which is something of this sort. Okay, so what is dy by d theta? Let me do it separately for you over here. So dy by d theta is a cos theta, and what is dx by d theta? So dx by d theta is nothing but a times minus sin theta, right? Clear? So if you just divide these two, what you will get is minus tan theta, or minus cot theta. Let me write it for you. So it will be minus cot theta. So if I say this is m, so what will be mn? That is slope of the normal. So slope of the normal will be 1 upon mt. If this is mt over here, so this will become what? Yes, it will become tan theta. Got it? Clear? So we needed the equation of normal. So for equation of normal, right, we'll use this as the slope and this as the point. So point, so you also needed the point. So point is already given, right? So point is x is equal to, so this is the beauty of the parametric form, that points are already given to you. You don't have to waste your time thinking about it. So equation of normal then can be here written as y minus a times sin theta is equal to m times, that is the slope, that is tan theta into x minus a 1 plus cos theta, right? This is how you can write. This is the equation of normal we were looking for. Okay, so let's simplify this. So if I simplify tan theta over here, it will become sin by cos, and if I multiply, so what I can get over here is y cos theta minus a sin theta cos theta, right, is equal to, this will become what? X sin theta minus a sin theta and minus a sin theta cos theta. This is what I'll get, and easily I can see that this particular a sin theta and a cos theta will get cancelled out. So what you people will be left with a equation something of a sin theta minus y cos theta is equal to a sin theta. This is what you people will get. So this is the final equation of the normal that you will get. Okay, so now you want to check whether it passes through a fixed point or not. So why I am saying a fixed point, let us understand that first of all. So you can see here that the equation of normal, so the equation of normal is in terms of a parameter. Equation of normal is in terms of parameter theta, right? So that means for different values of theta you will get different equation of normal. But for a fixed point, what do you mean by a fixed point? That irrespective of theta, it will pass through that point. This is the meaning of when we say independent of or a fixed point. So just match the answers that are given to you now. Can we easily find our answer? If you see the B option, if you just substitute a comma 0 in this normal, so what this will become, a sin theta is equal to a sin theta. That means LHS is equal to RHS always for any value of theta. So that means all the normals, irrespective of what value of theta you put in, they will all pass through this particular point, and this is our final answer. This is how you find question based on fixed point. Got it? So now let us understand the concept of angle of intersection of curves. So what do you mean by angle of intersection of curves? So it is actually equal to, you can say, angle between tangents at their point of intersection. Angle between tangents at point of intersection of the curves. Point of intersection of curves. This is what is the actual meaning of angle of intersection of curves, right? Angle of intersection of curves. So I have drawn a diagram in front of you people. So let's say if this is the curve 1, which is called as TF, so this is the C1 curve, and this is the C2 curve, which is GX curve. So tangent at the point, so they intersect at a point P, and P point is given by x1 comma y1. This can be given to you, or you will be required to find this point. Anyway, it could work around. So if we draw tangents at the point P to both the curves, so let's say for C1 curve, that C1, which is nothing but y is equal to fx curve, the tangent is given by TF in the diagram, right? And for the C2 curve, that is y is equal to gx, the tangent is given by TG. This is the tangent at point P, both of them, first of all, right? Okay, so now what is the slope? Let's say the slope of this particular will be MF, and let's say the slope of this particular tangent will be MG, right? If we can find the equation of tangent, that means we have the slope. So how do you can find slope? So MF is very easy to find. What you will do dy by dx for C1 curve at P, and similarly for MG, what you will do? You will do dy by dx for curve C2 at point P, right? So this is how you will find MF and MG. And then what is the formula for angle between the curves or angle between the tangents? So that is, we already know, is tan theta is equal to, yes, m1 minus m2 upon. So this is how this property has to be used to find angle between curves. That's it. This is your answer. You know, so you can take the inverse over here, that is theta is equal to tan inverse of this particular thing. So this phi, rather than this phi, or let's say I have written as theta, this theta is nothing but this particular quantity. So this is how you find angle of intersection between any two curves. Now let us apply the concept of angle of intersection of curves to a particular problem. It says that the curves given here, that is y, this is the first curve, that is let's say the C1 curve that is given to you is y is equal to 2x square minus x, and the C2 curve that is given to you is y square is equal to x. So these two are the curves. You know, there it is given that they intersect at 0, 0. We can easily see that if you put x equal to 0, both the y will come out to be 0. So they intersect at 0, 0. They intersect another point Q. Find the angle between the curves at the point Q. So this is something, a hypothetical diagram. Don't mind, because it should have passed from 0. So don't look into it. It is just to explain to you that again F1 and F2 are intersecting, and we need to figure out this point P over here. For example, here this P point is nothing but, it should be Q, right? So our target is to find Q. How you will find Q is very simple. You will have to substitute first of all the value of y from here to here. Okay, what value you will get? Can you tell me? after solving this, this will become 4 x raised to power 4, right, plus x square, right, and this will be minus 4 x cube equal to x. And if I write everything on one side, you can easily see that this will be a biquadratic equation which has one root as 0. Why is 0? Because x can be taken common, right? If you take x common, so this will become 4x cube minus x square plus x minus 1 equal to 0. So we know that from here x is equal to 0 is a solution, but we cannot take it because it is already given that you have to find another point q. So how you will do this now? So that implies the remaining quantity should also be 0. This is what we are interested in, 4x cube minus 4x square. So this 4 here, right, plus x minus 1 equal to 0. If you clearly see, this becomes something of, if you can take 4x square common here, so it will become 4x square plus 1 into x minus 1 equal to 0. And here this quantity will not be 0, so the only solution will be x equal to 1. So this is actually the abscissa of your point P, right? So this is your point Q whose abscissa is x equal to 1. And what will be the value of y? Just put anywhere, right? So what will be the value of y? If I put it over here, what will be the value? Yes, 1. Okay, so the point Q is nothing but 1 comma 1. This is where they will again intersect. Now our target is to find out angle of intersection at this point. Let me just remove this diagram to make sure that we can move ahead and apply the concept. Okay, so yeah, so now we have figured out the point. Now our target is to find dy by dx for both the curves. So dy by dx for C1 at 1 comma 1. This is the first target. So this is the first curve, that is y is equal to 2x square minus x. So what is dy by dx now? It is 4x minus 1, and you need to find at 1 comma 1. So this value will be, let's say m1 will be given by what value? Yes, it will become 3. Now let's say dy by dx we need to find for C2 curve. So C2 curve is y square equal to x differentiated. So what you will get, 2y dy by dx equal to 1, or we can say that dy by dx is nothing but equal to 1 by 2y. You again need to find this at 1 comma 1. So let me tell you that this is m2, so this will come out to be 1 by 2, and hence you can find the answer. So answer is nothing but tan theta is equal to, what you will do, 3 minus 1 by 2 upon 1 plus 3 into 1 by 2. This is how you will solve this particular problem, and this will give you the angle of intersection of the two curves at particular Q point. So this is your answer, that angle of intersection at Q. Got it? You just need to solve this. This is a simple calculation. If I have to solve this, this will become 6 by 5, and this will be what, 6 and 7. So yes, so theta is nothing but tan inverse 5 by 7. This is how you have to solve. These are very simple problems. Just focus on what is actually the basic of this particular concept. Now let's take another problem on angle of intersection of curves, and this is basically now for the orthogonal curves, right? So you are given that you need to find condition when these two curves mutually intersect orthogonally, right? Do you remember we studied this particular concept of orthogonality in circles? Orthogonal circles we did. So what do you mean by orthogonal, right? Orthogonal is nothing but 90 degree, right? So where we also say that we are orthonormal x's, right? X and y are orthonormal x's. So here they intersect orthogonally. That means angle of intersection of curves. Angle of intersection of curves is nothing but 90 degree. This is what is meant by angle of or basically orthogonality. So now if you want to apply this, it is straightforward that you need to find theta, and the theta should be 90 degree. And for theta to be 90 degree, we can say that m1 and m2 will be perpendicular, right? And we know that the condition of perpendicular line is, yes, m1 m2 n2 should be minus 1. So this is the particular condition that we are going to use in this particular question, that the product of the slope of the tangents to these two curves should be minus 1. So let's start applying this. So let's say it is x square by a square minus y square by b square equal to 1 is the first curve, and the second curve that is given to you is xy is equal to c square. Now let us assume that they intersect at x1 y1. Before even going for solving and finding, So I would rather say before finding point of intersection, right? Point of intersection, right? What you people should do actually here, let's assume that point of intersection is point of intersection is x1 y1, right? Point of intersection is nothing but x1 comma y1. So what is the derivative for this particular curve, c1 curve? Let's quickly solve this. So this becomes 2x by a square minus 2y by b square dy by dx equal to 0, right? So the dy by dx for this particular curve will come out to be what particular value? Yes, it will be x b square y a square. And if we want to find this at x1 y1, so it will be x1 y1 b square by a square. Okay, now we have taken that the point of intersection is x1 y1. Let's try and find this for curve 2 also. So this is our curve 2. So for curve 2, if I start, it will be y plus x dy by dx equal to 0, right? Because c square is a constant, don't worry about it too much. So dy by dx for this particular curve will be minus y by x, and at point x1 y1 dy by dx will be minus y1 by x1, right? So this is actually the short trick in this. You need not, I have seen students who immediately start solving for the intersection point. Wait, you do not have to immediately start solving the point of intersection. In many cases, it might be the case, it won't be even required. So now m1 for this is x1 by y1 b square a square, and your m2 is minus y1 by x1. You wanted to do what? m1 m2 is equal to minus 1. Let's, if you see, if you apply this over here, yes, got my point? You do not even need to find x1 y1. Why? Because they will cancel out. The only thing that you people will get here is that x b square by a square is 1, and this is how we get our answer, that b square should be equal to a square. This is your answer option B. That's it. So can you see that we were not asked to find angle, basically the point of intersection. Without that also we were able to solve this question, and that is the particular trick in this problem. Do not waste time ever in finding point of intersection when relation question is specifically there. Unless until it's ask you the point, as in the previous question we did, you can leave that part. I hope this question is clear. Now let us study another important concept, which though is not in the board syllabus, but still it might be asked in some other different entrance examinations. That is length of tangent, normal, subtangent, subnormal. I'll explain what do you mean by subtangent and subnormal, though the length of tangent and length of normal is quite comprehensible. So let's say you draw a tangent at a point x1 y1, which is p, right? And the curve that is given to you is, let's say, y is equal to fx is the curve, right? And you have drawn the tangent at p point, which is x1 comma y1. So what you can do for tangent and normals, extend the, first of all, extend tangent to cut x-axis, right, which is this t point. Okay, so they intersect at point t. Then extend the normal also, normal to cut x-axis, again the same condition. This is being done at m, right? So you have drawn the tangent and the normal at the point p, and we have drawn in such a way that we need to find their x-intercept. Okay, now if this is a p point, so PR is perpendicular to x-axis. That is another construction that we have done. PR is perpendicular to your x-axis, so that means this is the perpendicular. So what can you say about the R point? Can I say that R is x1 comma 0? Very simply, because it is perpendicular. So if I have to now define you the terminologies of length, so if I talk about length of tangent, right? So length of tangent is nothing but this distance, that is p until t. So length of tangent is known as pt. Similarly, length of normal will be the point from where you have drawn the normal, that is p, until this point of intersection with x-axis, that is pm. So pm is known as length of normal. If we have to talk about length of subtangent, now this is something new to you people. So length of subtangent is nothing but this tr distance. Okay, this tr And similarly, you can easily now reciprocate that the length of subnormal will be nothing than Rm distance, right? So these are the four terminologies that you people have to remember for this kind of concept. Our target is to figure out how you will do this, which is very simple. Why? Let's see. Let's say we find dy by dx at x1 y1, right? We will be given the curve, we need to find dy by dx, and we call this as, let's say, mt, that is slope of tangent. So what will be the slope of normal? Slope of normal, right? We know that we can calculate this, so this will be minus 1 by mt, and for the timing let me write this as nothing but mn, right? I'll replace it whenever I want to. That is slope of normal. So what will be the equation of tangent? Give me the equation of tangent now, quickly. Right, so equation of tangent can be written as, yes, by using the point slope form. So it will become what? Y minus y1 is equal to mt times x minus x1, right? And you need to find this t point to find pt distance. So t is nothing but x-intercept. So what will you do for x-intercept? For x-intercept we'll do, tell me. Yes, we'll put y equal to 0. Absolutely. So if you put this becomes y1 by m is equal to x minus x1, and that implies that x is nothing but what? The coordinates of this t point will become x1 minus y1 by m, right? Now you need to find pt, right? Let's say first of all we figure out pt square. So pt square will be what? x1 minus x1 minus y1 by m, right, square plus y1 square. Got it? So if you just calculate this x1 will get cancelled out, and what you will be left with is y1 square upon m square plus y1 square. And if you simplify, the y1 square can be taken common, and you will be left with 1 plus m square by m square. So if I simplify this particular quantity, the pt distance will become what? y1 by m under root 1 plus m square. So this is how you calculate length of tangent. Though we prescribe that you should remember this formula also, so in fact this is a formula that you people should remember, but if you are not able to, that is the reason I have done the proof part. Okay, so if you can remember this will be very great. Why? Because I can now tell you a trick to remember the PM distance, right? So PM is nothing but replace, for this I am writing here, replace m by minus 1 by m. Why I am saying this? Because we know that the slope for the normal will be minus 1 by m. So if you replace this, what you will get? Minus y m1, right? And this will become what? 1 plus 1 by m square, right? And if you solve this will again come out to be what? Yes, so this will be y1 under root 1 plus m square again, right? You can leave the negative sign, don't worry about the negative sign, because we are talking about the distances, so it always has to be in the modulus component, right? So this is how you can remember the formulas for the normal as well as for tangent, right? So these are the two particular answers. Now let us just quickly see how you will find length of subtangent and subnormal. Okay, we just calculated that t was this particular point, right? And we now need to find subtangent. Let's say if we want to find subtangent, right? So what is subtangent? That is length tr, right? So what will be the tr? Tr will be distance of these two, and since they both lie on x-axis, you can just subtract their abscissas very clearly. So it will be nothing but modulus of x1 minus y1 by m, very simply. So if you calculate this again will cancel out, and you simply will get what? y1 by m1 modulus. So this is the length of subtangent, as simple as you can get. Alright. And similarly, as I told you to figure out the formula for normal, though you can solve it on your own, I am again telling you the trick that if I have asked you subnormal, and if you know that the formula for subtangent is y1 by m, yes, so this will become what? Replace m by, again, what? Minus 1 by m, and this will become what? Modulus m by 1. So this is the answer for subnormal. That is how you figure out subnormal, subtangent, length of tangents, length of normal. Now let's apply this in concept in a particular question to just make sure that you have hold of this. So now let us apply the concept when you already know these formulas. For these formulas you can just go back to the previous concept that we just did, where we have derived how you get to all these particular answers. So you need to find the length of tangent and length everything at a point theta. Let's say this point is theta, and the curve is given in the parametric form. So don't worry about the parametric form. In fact, it makes the question a bit more easy, let me tell you honestly. So this is 1 minus cos theta. So this is the point at theta. This is given to you. Okay, now length of tangent is nothing but y1 by m. So first of all, let's try and find m, right? So you need to find dy by dx at point theta, right? So this will be nothing but dy by d theta upon dx by d theta, right? Minded this will should be x. Okay, so yeah, so this will become what? A 1 plus cos theta. Sorry, this should be the denominator, right? So this will be the particular value. So I can say m is nothing but, by doing the cancellation, the net value of m that I will get is sin theta upon 1 plus cos theta. So this is the value of m that you will obtain. Now the point, let's talk about the point, right? We always used to take the point. So point is in fact the parametric point only, that is already given to you. So point is, no need to waste your time in thinking, sir, what is the point? This is the point, right? So this is how the curve behaves when you are given a point at theta. So this is the point. So do not worry about what is the point. We are not given the point, how we'll find the point. So the point is this one, right? So if this is the point, now just apply the property over here. Okay, so length of tangent. So length of tangent is, let's say length of, we are finding length of tangent first of all. So it will be y1. So this is the particular value of y1 and this is nothing but x1, right? Though you can see that nowhere we are going to use x1. So it is a 1 minus cos theta, right, divided by m, right? So division of m will give you sin theta into 1 plus cos theta over here, into product of 1 plus sin square theta upon 1 plus cos theta whole square. So you just have to solve this as basic as it can get. So if you solve, this will become 1 minus cos square theta. 1 minus cos square theta is nothing but sin theta. So you should get actually a sin theta, because you will cancel out this. What value this will be obtained here? This will come out to be 1 plus cos theta after taking, and in the under root what you will be solving, 1 plus cos theta whole square plus sin square theta. So it will be 1 plus cos square theta, right, plus sin square theta. So this will become 2 and this will be plus 2 cos theta, right? And so this will be reduced to what particular value? Let's see, this will be a sin theta. Now it is just a trigonometry problem that we are going to solve. So this will become what? This will be 2 times 1 plus cos theta, and we know that 1 plus cos theta is nothing but 2 cos square theta by 2. So and if it take the under root, right, so what the value will be? 2 cos theta by 2. So the net answer of length of tangent will be a sin theta upon 1 plus cos theta. So you can again say that 1 plus cos theta would be simplified to, yes, 2 cos square theta by 2 into, this will become what? Yes, 2 cos theta by 2. So again, if we go on the further simplification, let's just first of all write what is left. Now you 2 and 2 will cancel out, will be left with this. Now sin theta can also be written as, yes, sin theta eventually can be written as some this particular quantity. So now again cos theta by 2 will get cancelled out. The answer that we are going to fetch for tangent is, this is the answer. Length of tangent is nothing but 2a sin theta by 2. So if you see, this is just a trigonometry problem after we know the formula. I am not going to solve the other 3 parts. You can solve, this is for your own practice, right? And it's very simple. You will not be asked very tough questions based on this concept, so don't worry about it. You just need to know what this concept is actually. Alright. Okay, now let us do derivative as a rate measure. So first of all, let us understand what do you mean by a rate measure, right? So this is a very important term because you already have studied this in class 11th in the topic kinematics. So rate measure is nothing but change of one quantity, right? Change of one quantity with respect to change in other, right? Change in one quantity with respect to change in other quantity. So this is what is the meaning of rate measure, change of other. So if you see, we can say that this is nothing but, let's say, delta y, that is change in y with respect to change in x. So this is basically a rate measure. But what if we say that we limit this delta x to be very small, right? So then this delta y by delta x, so you can call this as, yes, instantaneous change, instantaneous rate of change, right? So can you remember that we did this in acceleration topic, rate of change, instantaneous acceleration? So this was actually the if you talk about acceleration, so it is basically rate of change of velocity with respect to time. What is velocity? It is rate of change of distance with respect to time. So you have already gone through this particular definition. But if mathematically we talk about, so in mathematics, dy by dx is nothing but limit delta x approaching 0, delta y by delta x. So in a way, when you say dy by dx, you are actually saying you are finding the rate at which y changes with respect to x. So this is how dy by dx, this acts as rate measure, acts as a rate measure, right, for y with respect to x. And if you want to find this rate measure at a particular instance, right, if you want to find this at a particular instance, then you don't have to do anything, but you just have to find the derivative at that particular instance. For example, we are finding with respect to x, so you can say the value at x naught. This will give you the instantaneous rate of change at x equal to x naught. So this is the basic concept. In fact, this definition of dy by dx will also be used in the topic approximations and errors, right? We will be covering that too today. So this will also be covered in approximations and errors. So let's see how we are going to apply this concept in the question straight away. Okay, so the question says find the coordinates of a point on the ellipse where the ordinate decreases at the same rate at which abscissa increases. So how rate measure is coming into this picture is that ordinate is decreasing at the same rate at which the abscissa increases. So let's say if we talk about that they are decreasing with respect to something, they must be decreasing or increasing with respect to something. Let's start the question. I'll explain this in the midway. So it is given that 16x square plus 9y square equal to 400 is your ellipse. Now we want to introduce rate measure. It is given that the ordinate decreases, right? So this decreases. So do not get confused by which rate they are decreasing, in a way that you must be confused by what differentiation should be done. Should we find dy by dx, right? So this is not the target. Why? Because you are not trying to say that ordinate is decreasing with respect to x. Since it is not given at with respect to what it is decreasing, let's say we call that with respect to time or any other variable they are decreasing. So dx by dt shows the ordinate change of ordinate, and dx by dt, let's say, will show the change in abscissa, right? Very clear. X is the abscissa and y is the ordinate. Okay, so if we start just differentiating this, so this becomes what? 32x dx by dt plus 18y dy by dt, right? This becomes, and this becomes equal to 0. We do not need to differentiate any further. So now what is given? We wanted to find the coordinates. So that we want at a point where the rate of change of ordinate is same as rate of change of abscissa, but it is given that something is decreasing. So when something decreases, so let me talk about delta y. So what is delta y? Delta y is y final minus y initial always. So if something decreases, right? So if something is decreasing, what is the relation between yf and yi? Which one will be the greater? Yes, yi will be greater because it is decreasing, so yf will have a lower value. So this value delta y will come out to be less than 0, and since delta y is coming to be negative, we can say that dy by dt will come out to be less than 0 also, or we can say this will be a negative quantity. Keep this in mind, right? So whenever you have a quantity which decreases as a decreasing rate, you will take its derivative negative. So I can say that dy by dt in this particular question is nothing but minus dx by dt. This is the condition that is given to you in the question itself. Okay, because this particular quantity is decreasing, this is increasing, so there has to be a minus sign which actually signifies their relation. So you just have to replace this particular thing over here, so it becomes 32x dx by dt minus 18y dx by dt, right? And you can now take dx by dt common because we know that it is changing, so it cannot be equal to 0. What you are left with is 32x minus 18y is equal to 0. Okay, so we were being asked to find the point, right? So now we need to target the point. So if I write this, this becomes 18y is equal to 32x, or we can say y is nothing but 16x by 9. So this is our first quantity, and we know that this point lies on the ellipse, so it should satisfy the condition of the ellipse now. So just replace this value of y over here to find the values of x. So if you just simply put this value, so this will be what? 16 square x square by 9 square, right? This is something 400. Got it? So what you can say is, if I take 16x square common, which I can take over here, so this will be 1 plus 16 by 9 is equal to 400. I am just solving it. You can just solve it. So I'll just directly write what will be the answer then. So if you solve this completely, you should get that x square is equal to 9. And this implies that x is equal to plus minus 3, and since x is equal to plus minus 3, definitely you will get two values of y when you put it over here. So y you will get how many values? Yes, you will get two values again, that is plus minus 16 by 3. So there are 2 points at which the rate of change of ordinate is equal to rate of change of abscissa, right? This is how you solve this particular problem. Okay, now let's take the other problem. It says find the rate of increase of the length of shadow of a man 2 meter high due to a lamppost 10 meter high when he is moving away from it at the rate 2 meter per second. Right, so let me draw the diagram for you for this particular question. So let's say this is the path on which the man is traveling. Man is somewhere here, right? And it is given that its height is 2 meters. So this is actually is 2 in length, right? And let's say a lamppost is somewhere here. Okay. So lamppost is 10 meter in height. So here is the bulb, right? You can say this is the bulb. And now if he is traveling in this particular direction. Okay. So obviously as he will move, he will have a shadow because of this particular physics concept that you must have studied, right? So this is the shadow. So he will have shadow over here in this particular region. This is the shadow that he will have. Okay. So let's say I pick up a thing that the shadow is nothing, let's say first of all, this is the speed where v is given to be 2 meter per second, right? And the shadow of this man would be this region, right? This region will be the shadow. And I also highlight the triangle. Let's say this point is A, this point is B, this point is C, and this point is D. Let's say this point is E also. So now what is given? Now converting this analytical problem into mathematics. So B, that is the height of the men, will be 2 meters. CD, that is the length of the post, will be 10. So this, let's say, be y distance, and let's say this be x distance. So I have assumed that AB be of length y units and BC be of length x units, right? This is what I have assumed. What you want to find is that what is the length, rate of length of the shadow, right? Rate of increase of, so rate of increase of length, what it could be? Yes, you are thinking on the right term. So actually it is asking you the speed of the shadow. So speed is nothing but distance traveled per time. So actually the shadow, if I want to talk about the shadow rate, right? So the shadow rate will be nothing but dy by dt, because y component gives you the shadow. The rate at which y will change will give you the rate at which the shadow will change. And then what will be the speed of man? Can you tell me speed of man in terms of the diagram? So the speed of man according to my diagram will be nothing but dx by dt, because he is traveling in this direction. So how much distance he travels is given by actually x. So he is traveling at a constant rate of 2 meter per second. So dx by dt is nothing but 2 over here. Now I guess the question is very simple. You need to find a relation which will highlight x and y somewhere down the line. Okay, and since there are two particular triangles here, obviously the hint comes out to be that we will be using similar triangles for this particular concept. So we know that by similar triangles, which triangles will be similar? Let's say A, B and E will be similar to triangle AC D. So then I can say AB by BE will be equal to ratio AC by CD. What ratio this will transform to? This is y by BE we know is 2. AC will become x plus y, right? We know this, and this CD will be 10. So this is the relation, and if you solve this relation, what you will get? This will be something 10y is equal to 2x plus 2y, or we can say 8y is equal to 2x, or y is equal to x by 4. And we wanted not y, we wanted what? This is our target, dx by or dy by dt. You just have to differentiate. So dy by dt is nothing but dx by dt into 1 by 4, right? And we know that dx by dt is given to us, that is 2. So the answer to this final problem is nothing but 1 by 2. This is the answer. That's it. Okay, so the rate of the shadow of the man is increasing at a rate of 1 by 2 meters per second. This is what was asked of you in this particular question. So very famous question, it being asked repeatedly in some or the other form in competitive examination, and I would say it is one of the most easiest at the way, because you don't have to do too much of differentiation in this question. I hope this question is clear. So now let's take the other chapter, which is errors and approximations. And before we go further, we need to go some of the some of the basics of this. So the errors that will be asked here will be of two types. One will be the relative error, right? And again, I understand that you people must have done this again in the physics and unit and dimension topic. And the other would be the percentage error, right? So I just need to highlight what is percentage or relative error. So if you want to find relative error in terms of x, that is given by delta x by x, and you want to find percentage error, then this will be delta x by x into 100. Always delta x is nothing but what? X final minus x initial. So all the questions based on the errors will be falling in either of these two categories. So errors topic will be covered in these two particular cases, and we'll take some questions on how to do this. Okay, and I'll also take the concept of how to apply approximations by using this. Apart from this, what you people have to use in this is that we know that dy by dx is nothing but this definition. We just did this definition in the rate measure topic, right? This is the definition of dy by dx. So we somehow forget this limit, because always we'll take that delta x very small. So why we can say that dy by dx is equal to, let's say, delta y by delta x. So this is the approximation component, right? This is what we'll use in the approximation part. Okay, so this is the other important aspect that is going to be used extensively in this particular chapter. So let's say what is given is that if the percentage error in the length of cube is 1, then find the percentage error in the volume. So we know that the volume of the cube is nothing but V is equal to L cube, right? What is given to you is the percentage error in terms of L, that is delta L into 100 by L is given 1. This is given to you now. Now you want to find percentage error in volume. That means what you are trying to find is delta V by V into 100. That is your target. This is what you want to find. Okay, so now let's see how we are going to achieve this target and how we are simultaneously going to use all of this in the question. So here we know V is equal to L cube. Can we differentiate? What will be the derivative? Let's say we differentiate volume with respect to here length only. So dV by dl will be nothing but 3L square. So now you have to think of getting to these particular values which we want to find using this. So can we use this concept here? So let's say here we would use that dV by dl is nothing but delta V by delta L, right? Can we say this? Okay, so we want delta V by V. What we are given here is, let's substitute. So this becomes delta V by delta L is equal to 3L square. This is just how you will solve. Don't write it exactly in boards, right? Solve the process which your teacher must have told you, because board process follows a different approach. But yes, this is how you quickly can solve these kind of questions. So delta V by this. So you actually require V below, right? Let me just shift it entire thing over here. So this will become something like this, and now you want to divide this by V. Let's divide this by V, not a problem. So if I divide this by V, what this will become, delta V by V is equal to 3L square. What is the value of L? V? Yes, it is L cube into delta L. Let me take it over here. So what this question will become then? Can you tell me? Yes, very easily. So it becomes delta V by V is equal to 3, and you can say that if I cancel, this will be 3 by L delta L. And more importantly, this is now arranged in the form of percentage error in terms of L. Can you see here? Right? So it was nothing but given to us. We just need to multiply by 100 on both sides. So delta V by V into 100 is equal to 3 into delta L by L into 100. Now this is given to be what? 1. So this is nothing but 3. So delta V by V into 100 comes out to be 3. So that implies the answer is percentage error in volume is nothing but 3%. Right? This is how you solve these kind of questions. So I have written percentage, so I should not write here, but let's say. So the error in the volume is 3%. So this is how you will say this question. Got it? Okay, now let us apply in a very the same concept of errors in a very famous problem in the mirror formula. So the focal length of a mirror is given to you 1 by V minus 1 by U is equal to 2 by F. If equal errors are made in measuring U and V, let's say I take that error to be alpha, right? Then find the relative error in F in terms of alpha. So just to complete the question for you. So it is given that 1 by V minus 1 by U is equal to 2 by F. That is the lens formula is given to you people, right? The mirror formula. So if you have equal errors are made in measuring U and V, you have to find relative error in. So you want to find relative error. So what will be the relative error? Yes, relative error will be just delta F by F, no 100, because this is equal to relative error, and this is the target that we have to find in this question, relative error. Okay, so how we should proceed in this question? Give me a hint. No worries, just simply divide it, right? Oh, sorry, I'm saying divide, differentiate it. As simple as that. Very simple problem. So if you start differentiating with respect to t, differentiate with respect to, let's say, time. Okay, we can differentiate with respect to any variable. Don't worry about this fact. So this will be what? Minus 1 by v square dv by dt. This will be minus minus plus 1 by u square. What it will become? Yes, du by dt, and this will be what? Minus 2 by f square df by dt. So now in fact I would go a step further here to highlight that what we could do is partial differentiation. I'll try and introduce a new concept here to you people. You should understand this. It is called partial differentiation. So partial differentiation is when you do not know, with respect to what you have to differentiate, with respect to what to differentiate, right? Though this is not the exact definition, this is the layman what I am saying. This is the layman definition of explaining to you people, layman definition, right? So rather than saying dt, I can just now write that I just divide it. So something like this. You do not know the variable, so you are not writing it below. You are assuming that yes, since they are all related and they are all changing, so they must be changing somehow or the other, right? And they say that errors are being made, right? Errors. Okay, so what is delta V? Delta V will be V final minus V initial. So I can say this is the error here in this particular question, right? Because this has to be error. What you took and what was originally there is the error. I can say that delta V is the error then. So delta V is nothing but alpha given to you. And similarly delta U will become U final minus U initial, which was your error that you took UF, but it was originally UI. So this is the error. Understand it this way. So this will become what? Alpha times 1 by U square minus 1 by V square is equal to minus 2 by F square df, and df now can be written as delta f in approximation terms, right, as we just did in the earlier slide. So what we wanted was to find delta f by f, right? We already have delta f, but instead we have delta f square. So now let's write again. It becomes delta f by f square into 2. I will shift the minus sign over there. So this will become what? 1 by v square minus 1 by u square, right? You only need one f, right? Got it? So delta f by f into 2, I send one f over here. Can I do this? Right? What is the value of f now that you people have? You already have the value of f in the question, right? So just replace that value. In fact, what I could say that I can write delta f by f is equal to f alpha by 2, and I can then split this into 1 minus v into 1 minus u into 1 by v plus 1 by u, right? So what is 1 by v minus 1 by u? Can you see it here? It is already there with you, 2 by f. So it will actually get cancelled with this f by 2. This will be what? This value is nothing but 2 by f, so this gets cancelled out. So what is the answer that you get? That is delta f by f is nothing but 1 by, this will get cancelled out with this, 1 by u plus 1 by v times alpha. So this is the answer we are looking for. This is the relative error in f in terms of alpha, u and v, because u and v are given to us, and alpha I have taken in the question to make you sure that you understand what is to be found. I hope the question is clear. Let us take another very famous example to understand the concept of relative error. You want to find the ratio of relative errors in terms of t and e in the time period of a pendulum. So this is the time period of pendulum over here. So you need relative errors in t and l, the ratio, right? So relative error in t would be delta t by t, and you want to divide this by delta l by l. So this is your target, right? This is the target that we need to find in the question. So first of all, the target should be clear, what you need to find, what you need to extract. Okay, so now going by this, we are given a relation in terms of t and l, right? And believe me that here g is constant, so don't worry that whether g is a variable. Here g we will take it as a constant, right? That is the gravity force. How you want to differentiate? Obviously then only you will apply delta t by t. So for differentiation, let's say first of all take log, because that will simplify your process, right? Remember the logarithmic differentiation that we did the other day. So this could be written as log of 2 pi, right, plus 1 by 2 log t minus 1 by 2 log g, right? Understood? Now you want to differentiate. Now I'll differentiate. So if I differentiate now, what will happen? Log t derivative would be 1 by t dt, right? And again I'm doing partial differentiation, so I am least bothered about what value with respect to I am differentiating, right? So 1 by t dt will be, this will come down to be 0, right? And what this value will be, sorry, this is L, not T. Let me just correct it for you. Yeah, so this is not T, this is L that we have to take. Okay, so what this value will become then? Yes, 1 by 2L, I can say DL, and these all terms will be 0. So what you have got till now is that 1 by T dt is equal to 1 by 2L DL, right? Can you see that our question is already over? Why? Because if you see, I can write dt by t, right, dl by l into 1 by 2, and this could be then written as dt by t whole divided by dl by l is equal to 1 by 2, and we know that dt is nothing but delta t by t divided by delta l by l, which is nothing but 1 by 2, and this is your target. So answer is nothing but the ratio of relative errors in t and l is 1 by 2. This is the answer we were looking for. Very simple and straightforward problem. Okay, now let us take a question on approximation to understand how approximation works. So we need to find approximate value of under root 25.2. Okay, So now first of all, understand you need to figure out a function y is equal to fx for which this machine will work. Let us understand it with the way of machine, right? So what I understand of this particular question is that this is a under root machine, right? Because you need to find under root of something, under root of the input. Here the input that is given to you, I can say that input that is there is 25.2, right? So the question that will always be asked will be something of the sort, okay, tell me what is root 25. You know this value, right? This is nothing but 5. So they will always ask you these kind of questions in approximation where you know a particular value near about this particular input. So we know root 25, which is 5. Now we are asked to find when 25 is being increased by 0.2. So what is the under root machine? So I can say it is root x. So this is a machine which is working as root x. If I put x is equal to 25, I know the answer will come out to be 5, but you want to put x is equal to 25.2 and then you are trying to find what is the value of y, right? So how do we change this problem in the approximate case is, let me call this as the initial value of I and let me call this as the initial value of y. Let me call this as the final value of y, final value of x, and we need to find the value of final value of y. So can you tell me what will be the delta x? Delta x is nothing but x final minus x initial. So you have changed the input by 0.2. Then I can find delta y. Delta y will be what? Y final minus y initial. Though your target is always, if I always stay with my target is to find delta f, right? So delta f will be nothing but what? Sorry, not delta f, y final. So y delta f, so it will be y final is equal to delta y plus y initial. So this is what you need to find. Why I am writing something like this is because I know to solve in terms of delta y, because I know that delta y is approximately equal to dy. That is why I am writing something like this. Now let's turn this question in terms of derivative. So we were given y is equal to root x, right? Let's partially differentiate it, right? So what it will become then? Or let's say not even partially, you said dy by dx. I'll differentiate in with respect to each other. So it will be what? 1 by 2 x raised to power minus 1 by 2. Okay. And what will be the value of dy by dx at x is equal to 25? Can you tell me? So at x equal to 25, this value will be nothing 1 by 2 upon 1 by 5, which is nothing but 1 by 10, or I can say 0.1. So we have got that dy by dx is equal to 0.1. Okay, and we already did this, that dy by dx. What is dy by dx? So dy by dx is nothing but delta y by delta x, or in other way what I can say then, delta y is equal to dy by dx into delta x. Okay, so can you figure out the delta y component here, because you have already found dy by dx at x equal to 25, which comes out to be 0.1, right? And delta x, how much change you did? You changed the value of x by 0.2. So what is the value of delta y? Delta y changes by 0.2. Okay, so your target here was to find delta final. So what is the value of delta final that you will get from here? Yes, absolutely. So you people have got the answer that y final will be nothing but 0.02 plus y initial. Y initial y is 5. So the answer to this problem is nothing but 5.02. So this is the approximate under root of 25.2, and this is how you calculate, and you can apply this kind of process in each and every question of the approximate. Believe me, that is the reason it is a very standard problem. I hope this is clear. Okay, so by this we come to the end of the particular lecture for today, and we covered tangents and normals, rate measure, and your errors and approximation, and we did them in a very conceptual way, because they are not being asked very on a very difficult level at the entrance examinations as well as your board. So the video will help you in both of these territories. So what I will advise is that I'll be mailing you the worksheets. Do that. Plus again I will highlight that you should do NCERT exemplar along with this, right? Just do the NCERT exemplar so that your boards are also getting prepared and you are actually preparing the JEE Mains level content, which is the relevant content. Okay, so do this worksheet plus your NCRT as well. I guess that will be more than sufficient for the JEE Mains as of yet. And in fact, if you have prepared something, any notes by going to your own particular institute, just revise them. That will be more than sufficient. And if you have any problems in getting to a particular solution of NCRT, you can just go back to the channel, go to the exercise, find that question number on our channel and go to the video lecture of that particular thing. Right, I'll meet you again tomorrow with the other topic of AOD, because we have taken 3 days for AOD because of its prime importance. But this particular lecture will definitely fetch you marks, believe me. So if you are good at tangents and normal, definitely 4 marks are for sure at JEE Mains. So that is why I would say don't treat it as a very easy topic. Alright, good night, see you tomorrow.